Hello everybody, this is Venkat back again with session 3 of your Java basics for Hadoop for the Advanced Hadoop Developer module. We have finished off 2 sessions. We have seen how to create a project, how to compile and write our first program. Then we saw how to go ahead and talk about variables. What are the 3 types of variables? We have got our Eclipse in which we have seen our hello world that was done in the first session. Then we saw what is class variable, method variable, and instance variable. So hope things are clear as to what we have done till now. So we spoke about what is the difference between static and non-static variables too, and we have seen how static variables would be created without creating an instance of the class, whereas non-static variables needs a instance of the class. Similar thing applies for methods too. So now let's talk about our session 3. That's what we are going to start with today. There we go. So today we are going to talk about what is static and non-static methods. Okay, then we will talk about what is constructors, that is used to initialize the variables, and you would also see references to this and super keyword in our sessions as we go ahead. So that's what we are going to see today. So let's start with static. We saw that static, anything that is static is associated at the class level, let it be a variable or let it be a method, whereas non-static is always associated at the instance level. We also saw that static variables and methods can be called with the class name, although we haven't seen an example. We will see that. And we saw an example of non-static variable being called with the help of, let me go down to this instance variable, non-static variable being called with the help of an instance. We saw this. Okay, so today we are going to talk about static methods, and that will also answer to your question if you have it in your mind as to why is main static. Okay, so let's take an example. So when I say static, as you know, it is associated with the class, and static methods can be called directly with the class names. The reason why we have static methods is so that it can be called and shared by all the instances of the class. Similar to the static variables, static methods can also be shared by all the instances of the class. Now, when you compile a program, there is an auto compiler that is there, and if you go down to the project, you see here build automatically. That means whenever you will keep on typing, as we discussed on day 1, we saw that the compilation happens. Presumingly, if that is not the way how you have done it, if you had done it with the, oops, sorry, let me click on no. Oops, that would have mean that the files that I have created would have gone, but that's fine. So I have brought back the code and I have typed whatever I had closed it by mistakes. I have saved it. So we were talking about static, non-static keyword, and we were talking about static, non-static methods. So the reason why main is declared as static is because static means it is available at the class level. So like I was mentioning that there is an auto compiler which will be there by default whenever you are compiling it, and I have already shown you when you click on the project in the build, automatically the compilation happens. But when you run your program, what is actually called is the interpreter calls your class name dot main directly. So the instruction given to the interpreter is, let me make a note of this, the instruction given to the interpreter is to call the main. So interpreter is what is the entity or the program which starts execution. There are 2 parts. There is a compiler. Compiler compiles the program, and this results in a .class file. dot class file is the output of the compilation. The interpreter executes the dot class file. Okay, so that's why it's called as an interpreter. So the instruction given to the interpreter is to call the main method of the class which it is executing. Let me put this into a word wrap. So in our example, if we run this program, because it is the name of the class is instance variable main.java, it will call instance variable main.main. Now, if a method, like I said last time, has to be called directly with the class name, then that method has to be declared as static, right? So that is the reason why our main method is also declared as static. So static methods and variables can be directly called with the class name. They don't need a instance at all. So let's take an example. So I'm going to create a class over here, and let me call it as static method main, so that we know that this is the entry point. And what I want over here is that I want to have two classes. Since they're related, I'm writing it inside the class itself. Let me have a class called as static method, and let me have a class called as non-static method. In the static method class, okay, I need my curly braces. That's why it was giving an error. Remember, I mentioned that auto compiling is happening at the back. So now I'm going to have a variable called as int a is equal to 10. I initialize a class variable, and I'm going to say int b is equal to 20. I'm initializing another class variable. In static method, I am going to have a method called as static. It's static method, right? So it will have a static method. Static void met1, that is method 1, which is simply going to print out the value in static method is equal to plus a. And similarly, in the non-static method, I will have a method called as void met2, and in that I am going to say sysout of the value in non-static method is plus b. Okay, and that's it. So let me save this. So the moment I write this, the compilation happens at the back, and it says that A is having some problem. Why? Let's go ahead and check it out. It says cannot make a static reference to a field that is non-static. Remember, I mentioned some time back that static methods can be directly called with the class name. So if it can be directly called with the class name, when I call this method, okay, the class will be loaded. But when the class is loaded, would you get a memory for A? No, because A is non-static. Remember, when are memory given to non-static variables? Only when an instance is created, not when a object is created, right? So that is the difference between static and non-static variables and methods. So static variables get a memory when the class is loaded, whereas non-static variables gets a memory only when an instance is created. So now that is the reason why static methods cannot access non-static variables. So that's the reason why this error is coming. So let me document it over here. Static methods can access only static variables and not non-static. Okay, so the same thing applies for can apply static variables or methods. Same thing applies for methods also. So in main, you cannot call anything that is non-static. Remember that, because main is also a static method, friends. Okay, cool. So now, since I have got this ready, we know that. Let me document this over here too. We know a compiler. We know why the main should be declared as static. The instruction given to the interpreter is to call the main method of the class which it is executing. And since main is called with the class name when execution is going to be started, it should it means the main method should be declared as static. Okay, hope that is clear. Okay, the next point to remember is static methods can access only static variables, as non-static variables are given memory location only when a instance is created. So whatever I have orally said, I put it into a document so that it becomes very crystal clear. Now we know that this will not work. I have to make this a static, because static methods can access only static variables. Now the point is, how do I call these variables? I mean these methods. I want to call met1, okay, and I want to call met2 too. So for calling met1, since it's a static method, it can be called directly with the class name. I say static method dot met1. See, I don't even have to create instance of the class, but for the non-static method, I will have to say non-static method m is equal to new non-static method, and then I have to say m dot met2. Okay, so please note, static methods, although it can be called with the class name, it is not wrong if you call a static method or a variable with the instance name. So if you see in the last example, wherever we had our instance variable main example, we were calling a static variable with the instance name. That is correct. So that's the reason why it was giving you warnings over here. See the warnings. What does it say? The static field should be accessed in a static way. This is just a warning. The moment you see a cross, that means the code will not compile further without you changing that. But then if you see a warning, you can ignore it, but then you will you're doing something wrong. So it's saying that a static variable should be accessed in a static way and not in a non-static way. Although it is you can do that, there is nothing syntactically wrong with it, but then it tends to become semantically wrong. So that is why you were getting, only in this example, you were getting an exclamation mark, which says that something is a warning in the program. So now, since I have got two methods and I have mentioned to you how static methods can access only static variables, let me run this. So I'm running this program as a Java application, and it prints me the two values that I'm expecting. The value in the static method is 10 and the value in the non-static method is 20. So hope the concept about static, non-static methods are clear, friends. The next thing conceptually you should know is a constructor. Okay, so what is a constructor? Constructor, as the name suggests, is used to construct an object and initialize the variables with some value. So I would say constructor is like a method having the same name as the class name, but without a return type, and is used to initialize the class variables with some values at the time of construction. Okay, the next point is they are automatically called when a instance is created. So please remember the word instance. A lot of people get confused with the word instance and the word object. They tend to use it synonymously, but that's not the case. We know what is an instance. We have seen it in our very first day. Let me go ahead. No, second session. For calling methods of a class, we have to create an instance of a class. Instance would mean a memory. Creating instances means creating memory location for the classes, and this is what you'll be getting: a copy of all the non-static variables and non-static methods of the class, and a reference to static variables and methods of the class. So if you look at the word object, object is basically a C++ terminology, although people tend to use it interchangeably. Okay, object is without a memory and instance is with a memory. So it's very important that when you use a term, even the person who is listening to you should understand it in the same regard. So let's go ahead and run this program. We have seen that this is what the output is. Now let's move down to the next topic, folks. So we have seen what is static, non-static. We have seen a constructor. We have seen what is the difference between a instance and a object. People typically tend to use it in a different way, but then that should not be the case. Now, to show you a constructor example, let me say close all. Let me create a new class called as student main. And in that, what am I going to do is I have got a class called as student main. Outside this, I'm going to have a class called as student. The student will have some attributes like, so let's say the student has got an attribute called as string name and int marks. Now, we saw in the last time's example also to initialize the variables, we had kept a function that was used for initialization, right? So if you look at here, class variable .java, we had a function that was used to initialize the variables. Now, that is typically done in the constructor. You don't have a function to initialize the variables. We did that because we were testing it for the first time. So ideally speaking, like your method, we will have a method having the same name as the class name. This method will not have a return type. A normal method should have a return type. A constructor will not have a return type. Method and constructor both can have parameters like string n and I would say int m. And the main purpose of a method is instantiation. Just one sec, let me close my bracket and then a curly braces. The most important purpose of the constructor is to initialize the variables. The purpose of a method is not to initialize the variables, its behavior. We saw that a class will have two things, a state and a behavior. So the purpose of a method is behavior, whereas the purpose of a constructor is initialization of the variables. You don't typically use it for anything else. So what will I do over here is I would say my name is equal to n, like the way what we did in our class variable example. We will say marks is equal to m. That's it. And this is how you instantiate it. Now you might have a business logic method. I will keep the same method called as display, which will simply display out the name and the marks of the student. So that is what is the purpose of the constructor, to initialize the variables. Now when is a constructor called? It is called automatically when an instance is created. So when I say student, z is equal to new student, and I pass to that the name of the student. Let's say this is Rakesh, and his marks. Let's say he's a very studious student, so he got 97 out of 100. Okay, and now I can call the function called as x.display, which will display the ID and the marks of the student. So this is what is a constructor. So whenever we created an instance of the class over here, we were actually calling the constructor of the class. So that is the subtle difference in between calling a method. Like in this example, when I call a method, method needs to be explicitly called, whereas constructors are implicitly called. Let's make a point about that. Methods needs to be explicitly called, whereas constructors are implicitly called when a instance is created. created, small typo, and let's go ahead and test it and see if that works fine. So I'm just going to run this as a Java application, and you see the Rakesh, his name and his marks are printed, folks. So this is how you will have constructors in your example. We saw what is static, non-static methods. We saw what is constructors. Now there are two more keywords that we will touch base in this session. That is the this and your super keyword. Okay. So this keyword is used to refer to the class variable. So in my current example, you saw here that there is a name, that's a variable of type string, and here in the parameter, whenever I say string, I kept another variable. Now what will happen if it is of the same variable? So if I just say name is equal to name, there would be a loss of information, right? So which name am I talking about? So this keyword is used to refer to the class variable when the parameter variable or the method variable hides the class variable. So whether you are having a parameter or a method variable, it will hide the class variable. That is what is the purpose of the this keyword, current class variable. Super is different. As the name suggests, super. Super keyword is used to refer to the base class variable or method which is either hidden or overridden in the subclass. So whenever there is a parent-child relationship, the subclass can add more functionalities to the base class, and the methods are typically overridden, whereas variables are typically hidden. So that's the difference between this and super. Let's quickly take an example to understand this. Let me go back and let me say file close all. I'm going to create, hey, the student main I had created by mistake inside outside the package. So let me drag and drop this and you will see that it is automatically moved in. Now I'm going to create a new class called as this test 1, and let's see what's there in this example. So what am I going to do over here is, let's say I have got a class variable called as int a is equal to 10. I've got int b is equal to 20. I've got a function in the same class called as void met1, which will say a is equal to 30, and I would say int b is equal to 40, and then I'm going to print out my sysout of my a, which is a plain a. Then I will write sysout of my this dot a, because there are a here, there is an a here. So let's see what this is a refer to. Then I will have a sysout of b, and I will have a sysout of this dot b. Okay, so that's done. And then, like how we call in the main function, I will say this test t1 is equal to new this test, and I will say t1 dot met1. So let's analyze this and see what do you think would be the output. So here I have got two class variables. Here I just said a is equal to 30. So that doesn't mean that I'm declaring a new variable. I'm changing the value of the same variable to 30. So whether I say a or this dot a, both will point to the same memory value. So both the cases is going to give you 10 and 10. A lot of people would feel that a would give me 30 because it will refer to the most a local variable, and this dot a will refer to the class variable, and the class variable was 10. But then when I said a is equal to 30, I'm changing the class variable itself to 30. But this is different over here. Step number 9. I am reinitializing another variable, because the moment you declare it with a type, you are not using the variable, you are reinitializing the variable. So you are reinitializing the variable b with a value of 40. So this becomes a method variable, and you will have in the class one more variable of the name b, which is of the value 20. So now if you just say B, it will always refer to the innermost variable. So it will give you 40. And if you want to refer to the class variable, you will have to say over there this dot B. So that is the significance of the this keyword. In many cases, this is implicitly used if the variable names are different. If the variable names are same, then you need to explicitly use this, otherwise it will give you some unpredictable output. So you can say here A giving me 30 in both the cases, whether I say A or this dot A, whereas B is giving me 40 for the local variable first and then 20 for the class variable. So this is the use of the this keyword. So since we are not going to learn the whole Java topic, but then what is important from the MapReduce and the programming part of it, this keyword is a pretty important keyword. Similar to this, we have got a super keyword. Like I said, it refers to the base class. So let me create a class called as super main.java. So I have created that class. Now to make this program work, I need a base class and a subclass other than the main class where the program is going to be running. So let me create a class called as base, which will have a method variable. Let's call it as int a is equal to 10. It will have a function called as void met1, and just to ensure that it comes in the same screen, I am writing system.out.println of in base here, so that we know when I print this, this is what needs to be called. Then I want to have a class sub, but now the class sub is going to be the child class or the subclass of the base class. So for doing that, for showing inheritance, like in a C++ wherein you use colon, here we will use a keyword called as extends. So in MapReduce, this is used extensively. Whenever you want to use the attributes or methods of a class, typically in a MapReduce program, you would be extending some class. So extends keyword is very important. So let me correlate this, because the main purpose of doing this Java is because you want your MapReduce programming to be easier. So it is very important that we touch base with what you will be doing in MapReduce later on. So you would see this extends keyword used a lot when we talk about MapReduce programming. So I would say class sub extends my base. Now, whenever you have inheritance, by default, all the methods and variables of the base class is inherited. Of course, there is a difference when we talk about access modifier, but other than that, everything would be inherited. So now if I say over here int a is equal to 40, so what am I doing is my variable a of the subclass is hiding the variable a of the base class. So I would say subclass variable is being hidden, is hiding the base class variable. Okay, and now if I have a function called as void met1, again here there was a met1 in the base class, but you are also having a method called as met1 in the subclass, and inside that I am going to say in subclass. So the subclass method is overriding the base class method. So now if I go down to my main and if I create an instance of the subclass, if I say over here sub s1 is equal to new, or let me say s1 is equal to new sub, and if I say over here sysout of s1.a, it will call the data members and variables of the subclass. So it will only print me 40. Let's test it out. So when I run this, you see that it is going to print me 40. It is going to print me the variable that is there in this class. So it is going to print the hiding variable, not the hidden variable. So if you want to refer to the hidden variable, you will have to say sysout, but then again if I say sysout super over here, this class, the super always refers to your immediate base class. So the super has to be called over here. So what we will do over here is, let's write one more method called as void call base class. Okay, this is just to have a meaningful name, and inside that if we say sysout of my super dot a, so you would see that super is a keyword. All keywords start with small alphabets. This is for calling the methods and variables of the base class. So this is for calling basically the base class variable of A. And I will have to call this method over here. So let me say my S1 dot, I would say call base class. And now if I run this, you will see that first it will print me 40. That is logical because I have printed out s1.a. It will print me the value of a. And if I say s1.call base class, it will call this base call, and it should be class. I don't know why I wrote it as call. That's fine. It will print me the variable of the base class which is hidden in the subclass. That is 10. The same rule will be for the methods also. So if I say s1 dot met1, it will call me the method of the subclass. So if I run this, you would see that I didn't save it, that's the reason. So you see that first it prints in subclass. So see over here, of course it will print me in subclass. Now if I want to call the base class method, I need to say super dot met1. Okay, that's it. And what this super keyword will do is call the base class variable which is overridden in your subclass. So when I run this, it should first print me the base class variable, the subclass variable, that is 40. Then it should print me the base class variable 10, and then it should print me whatever is the base class method, that is called as in base. And then when I call s1.met1, it will call me the variable of the function of a met1, that is in subclass. Okay, let's test it out. So when I run this, you see here first it printed out 40. That 40 is for this one, system.out.println. Then when I call the base call, it has printed the base class variable, that is 10, and it has printed the base class method, that is in base. And then when I come down to my code and I say s.met1, it has printed me the value in my met1 in the class sub, that is called as in subclass. Okay. So hopefully the concepts are clear as to what we have done today. So today we started with static, non-static methods. We had already seen what is static, non-static keyword in the last session. That static keyword is associated with the class, non-static is with the instances of the class. Static, if a method is static, then it can access only other static methods, and main is declared as static so that it can directly be called when an instance is created. Similarly, after that we saw constructors, whose main purpose is to initialize the class variables, and we saw how by having a constructor our life becomes very easy. And then we saw what is the this and the super keyword. This keyword is always referring to the current class variable when when there is another variable that is hiding, or so let's say it's hiding and overriding is in the subclass. So if you want to see what is this keyword, when a method or a variable has the same name in the same class, I will use this to point it to the class variable, and super is for referring to the base class variable or method of the subclass. So hope you found the current session interesting, guys. So after every session, please go ahead and code these examples. These examples will be shared with you. So please go ahead and test out all these examples. That is what is very important. So that is the end of our session 3 of our Hadoop developer module. We will continue with our session 4 in the next class, and what we will do over there is, after we finish up a couple of sessions before we wind up, I will also take you through a sample map reduce code so that you would know that whatever we have done till now, you are in a position to understand that too. Okay, so that's it from my side. See you in the next class. Thank you.